Hello students, welcome again. In today's class, we'll be starting with the next chapter of organic chemistry. Already we have done halogen derivatives. Now we'll be doing functional group 1. Well, as per functional group 1 is concerned, this functional group consists of oxygen containing compounds like alcohol, phenol and ether. So first we'll be doing alcohols and phenols. We'll be saying alcohols and phenols, and whenever we talk about a functional group, we initially start with their IUPAC naming or their structure, and then we move on to their preparation, their properties, physical properties and chemical properties. This is what we are going to do here also. First I'll talk about alcohol and phenol. After that we'll talk about ethers. Well, if I talk about an alcohol has got a general structure like this, RCH2OH, where R can be an alkyl group or a hydrogen. So this is an alcohol. And if I talk about a phenol has got a structure like this. It has got a benzene ring which has got a OH group. So this is a phenol. Well, both of them, they are very much different in their properties. But before starting with their properties, first we'll see their method of preparation, how to prepare them. So we'll start with preparation of alcohols. How we can prepare alcohols? Well, their preparation can be done from alkyl halides. This reaction we have already done in alkyl halides, but I'll repeat this reaction. Suppose you got a alkyl halide like CH3, CH2, Cl, and you are reacting it with aqueous KOH. Then K positive will combine with Cl negative and will come out as KCl. And this OH negative will attack on this carbocation, leading to the formation of an alcohol. So we'll get a compound like CH3, CH2, OH. So this is how we can prepare an alcohol from alkyl halide. Well, we can also prepare alcohol from aldehyde and ketone. But before starting with that, I would like to tell you one general trend, means how alcohols they are formed. See, if I oxidize an alkane, on oxidation it will give me an alcohol. An alcohol on further oxidation will give me an aldehyde or a ketone. A ketone or aldehyde on further oxidation will give me carboxylic acid. This general trend was there in the 11th standard also. I give you one example for that. Supposedly I have got methane and I am oxidizing this methane. Well, oxidation is what? It is the addition of oxygen or removal of hydrogen. So I will get a compound like CH3OH. On further oxidation, it will give me a compound HCHO. Well, in this step, what will happen? Two hydrogen from methanol will combine with oxygen. They will come out as H2O. I'll get formaldehyde, methanol, which on further oxidation will give me HCOH, that is methanoic acid or formic acid. So this is the general trend. This is how it happens. If we want to prepare alcohols, we can prepare alcohols by the reduction of aldehyde and ketones or by oxidation of alkanes. So we'll see this thing. Now that's why the second preparation we have got is from aldehyde and ketones. Preparation from aldehydes and ketones. How can we prepare alcohols from aldehyde and ketone? We'll see that. As you can see here, what I have written, that reduction of aldehyde and ketone can give me alcohol. So we'll start with that. That is by a reduction. By reduction of aldehyde and ketones. We can use two different reducing agents. We can use lithium aluminum hydride, or we can use sodium tetrahydrogen borate. There's a difference in the reducing power of these two reducing agents. LiLH4 being a strong reducing agent can reduce all the carbonyl groups, no matter whether they belong to aldehyde or ketone or carboxylic acid or their derivatives. But as far NaBH4 is concerned, that's a weak reducing agent. It can reduce only carbonyl groups belonging to aldehydes and ketones. For example, see, I'm giving you one question which is there in your textbook also. Suppose I've got a compound like this. This is cyclohexanone, and here CH2, C double bond O, O, CH3. This is the compound I have got. And I am reducing this compound by NaBH4. As I told you that NaBH4 being a weak reducing agent will reduce only carbonyl group belonging to aldehyde and ketone. So this NaBH4 is not going to reduce this group. This is a carboxylic group, carbonyl group belonging to carboxylic acids, whereas the carbonyl group which you have got here belongs to aldehyde and ketone, so it will get reduced. As a result of that, I will get a compound like this, that is OH, CH2, CO, O, CH3. So selectively NaBH4 will reduce carbonyl groups belonging to aldehyde and ketone. It will not reduce carbonyl group belonging to carboxylic acid or their derivatives. Now here, if we talk about reduction, the first point I would like to tell you is that aldehydes on reduction will give you primary alcohols. So reduction of aldehydes will give you primary alcohols. Suppose I got a compound that is CH3, CHO, acetaldehyde or ethanol, and I am reducing it with NaBH4. I will get a compound that is CH3, CH2OH, that is ethanol, which is a primary alcohol, 1 degree alcohol I am getting. Likewise, reduction of ketones. Ketones on reduction will give me 2 degree alcohols. Here in this case, I am taking a ketone that is acetone or propanone, that is CH3COCH3. On reduction with NaBH4, it will give me a compound CH3, CHOH, CH3. This compound is propane 2-ol. So I am getting a 2 degree alcohol. So aldehydes on reduction will give you primary alcohols, whereas ketones on reduction will give you aldehyde on reduction will give you primary alcohols, whereas ketones on reduction will give you secondary alcohols. Now the question comes to our mind, can we get 3 degree alcohols by the reduction of aldehyde and ketone? No, we cannot. Then in case we want to prepare 3 degree alcohols from aldehyde and ketone, what we need to do? We'll react aldehyde and ketone with Grignard's reagent. In that case, we can get 3 degree alcohol from aldehyde and ketone, and we'll see how it happens. So from aldehyde and ketone, the second part I have got is by reaction with Grignard's reagent. You know that very well, that is RMgX, alkyl magnesium halide. So here I've got the Grignard's reagent. We'll see how the reaction occurs. Well, in that, I would like to tell you one thing, that formaldehyde, HCHO, on reaction with RMgX will give you primary alcohol. We'll see how the reaction proceeds. Formaldehyde is this compound. I'm reacting it with, say, methyl magnesium bromide in the presence of dry ether. Dry ether is a solvent of organometallics. That's why I'm using it. Well, as far alkyl magnesium halide is concerned, methyl magnesium bromide, magnesium is a metal and carbon is a non-metal. That means carbon is more electronegative. So this bond will break where carbon will acquire a negative charge and magnesium will acquire a positive charge. If I talk about formaldehyde, in formaldehyde the pi electron will move toward oxygen, that will become negative and carbon will acquire a positive charge. So what will happen? This methyl group which is negatively charged will attack on the carbocation and Mg positive which is positively charged will attack on the oxygen. I will get an additional compound like this OMgBr and here I will get CH3. In alkyl halide, I already told you one thing that the reaction of Grignard's reagent is always followed by hydrolysis. So we'll add some dilute acid into this, that is H2O in the presence of H positive. In this case, water will break into H positive and OH negative. H positive will replace Mg positive. So what compound I will get is HCH CH3 OH plus Mg OH Br. If you have a look at this alcohol, this is a primary alcohol because I can write it like CH3 CH2 OH. Ethanol, it's a primary alcohol. So formaldehyde on reaction with Grignard's reagent will give me primary alcohol. Whereas if I talk about any other aldehyde will give me secondary alcohol. Let's see that also. Suppose I have got acetaldehyde. Acetaldehyde is CH3CHO. Any aldehyde, that's why I'm writing in general form RCHO. Any aldehyde on reaction with the Grignard's reagent will give us secondary alcohol. Any aldehyde on reaction with Grignard's reagent will give you secondary alcohol. Let's do this by taking an example of ethanol, that is acetaldehyde. I'm reacting it with CH3 MgBr. Again in the presence of dry ether. Well, again it's Mg positive and methyl is negative, pi electron oxygen is negative and carbon is positive. CH3 negative will attack on the carbocation and Mg positive will attack on the oxygen, leading to the formation of a additional complex like this OMgBr. This on hydrolysis will give you compound CH3 CH CH3 OH plus MgOH Br. This can be written as CH3 CHOH CH3. So the compound I am getting is a 2-degree alcohol, that is propane to all. Once again, the reduction of aldehyde and ketone will give me primary and secondary alcohol, not tertiary. If I want 3-degree alcohol from aldehyde and ketone, I have to react them with Grignard's reagent. Formaldehyde is going to give me primary alcohol, any other aldehyde will give me secondary alcohol, and ketone they'll give me 3-degree alcohol. So now we'll see the same reaction with ketones. The third one is RCOR, that is a ketone, will give you a 3-degree alcohol. Here in this case, I'll show you acetone propanone. So the compound I have got is this. I am reacting it with CH3 MgBr in the presence of dry ether. I will get an additional complex, that is CH3, 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 OMgBr. This on hydrolysis will give me a compound, that is CH3, 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 OH plus MgOH-Br. So you'll see this is a 3-degree alcohol. This compound is 2-methyl propane 2-ol. So ketone on reaction with Grignard's reagent will give me 3-degree alcohols. This is all about the preparation of alcohols from aldehyde and ketone. By now we have done preparation of aldehyde and preparation of alcohols from halogen derivative, preparation of alcohols from aldehyde and ketones. In that we have seen that a reduction of aldehyde and ketone gives us primary and secondary alcohols, whereas the reaction of aldehyde and ketones with Grignard's reagent gives us primary, secondary and tertiary alcohol. Formaldehyde will give us primary alcohol, any other aldehyde will give us secondary alcohol, and ketone will give us 3-degree alcohol. Now we'll move on to the third part, that is preparation. Third one is from alkenes. How can we prepare alcohols from alkenes? Well, in that we'll see, the first step I'll tell you is by hydrolysis of alkenes. So alkenes on hydrolysis gives you alcohol. Whenever we talk about dehydration of an alcohol, we carry it out with the concentrated H2SO4. But whenever we talk about hydrolysis, for that we use dilute acid, that is dilute H2SO4. So here in this case also we will use dilute H2SO4. And we'll see how this reaction proceeds. Now suppose you have got a compound that is CH2 double bond CH2 plus H2O. In the presence of an acid, the water will break up into H positive and OH negative. In the presence of water, the pi electrons will come toward one of the carbon atom. One of the carbon will become negative, another carbon will become positive. So OH negative is going to attack on the carbocation and H positive is going to attack on the anion, leading to the formation of an alcohol, that is CH3, CH2OH, which is a primary alcohol. So this is how we'll get primary alcohol. Well, this reaction, as far the part of this reaction is concerned, you have got mechanism of this reaction in your syllabus. So we'll see mechanism also, how to carry out this reaction or how this reaction goes on. Mechanism. Well, initially what happens in the first step, H positive from acid H positive from acid combines with H2O and it forms H3O positive. In the second step, CH2 double bond CH2 plus H3O positive. The pi electrons will move toward one of the atom, that will become negative, another one will become positive. The H positive from H3O positive will attack on the negative one. When it will attack on the negative one, it will form CH3. So you will get CH3, CH2 positive along with water. H3O positive has donated a proton to the carboanion and itself it has got converted to water. After that, in the third step, CH3, CH2 positive, this carbocation will attack on the water molecule which has got lone pair of electrons. So this positive can easily attack on this lone pair. It will get attached to the lone pair and you'll get a compound CH3, CH2, OH2 with a positive charge on the oxygen atom. Because oxygen has donated its lone pair of electron, that's why it will acquire a positive charge. And in the last step, that's the fourth step, CH3, CH2, OH2 positive. See, oxygen itself is second most electronegative element. When it acquires a positive charge, its electronegativity further increases. So it becomes capable of withdrawing electrons from hydrogen and releasing hydrogen as H positive ion. So it will withdraw electrons from hydrogen and will release hydrogen as H positive ion. So you will get a compound that is CH3, CH2, OH plus H positive ion. Now H positive ion is what? Acid is what? It's a catalyst. It was used in the first step and it was regenerated in the last step. So this is the mechanism of hydrolysis of an alkene to form alcohol. Well, as far this hydrolysis is concerned, it moves in accordance with the Markovnikovs. Suppose I have got a alkene like CH3, CH, double bond CH2 plus H2O in the presence of H positive, definitely I will get isopropanol. I will get this compound. Now how it happens? The pi electron are going to move toward this carbon only. This carbon will acquire a positive charge because you know that 2-degree carbocation is always more stable than 1 degree. And in chemistry, the reaction proceeds to get itself stabilized. The molecules, they react to become more stable. So the pi electron will move in such a way that more stabilized carbocation is formed. That is, the 2-degree carbocation is formed, which is then attacked by OH negative ion, leading to the formation of isopropanol or propane 2-ol. This is a 2-degree alcohol, that is propane 2-ol. Now the question comes to our mind, if we want to prepare propane 1-ol, if we don't want to follow Markovnikov's addition, do we have a method of doing that? Of course, we have got a method of doing that, and that method is hydroboration oxidation. This is what we are going to see the next from alkene. So from alkene, the first step we have done. The first one is by hydrolysis of alkenes. The second one we'll do is by hydroboration oxidation. So second step is by hydroboration oxidation. In this step or in this method, you will observe anti-Markovnikovs. Anti-Markovnikov addition you will observe, or peroxide you will observe. So let's see how the reaction occurs. Suppose I have got 3 moles of CH3, CH, double bond CH2. I have taken 3 moles of propane and I am reacting them with half mole of B2H6. Well, if I am writing half mole of B2H6, that means BH3. Half mole of diborane or simply a borane. Well, in this case, homolysis occurs. You have to pay attention toward this reaction, how this reaction is proceeding. What will happen in this double bond? Homolysis will occur. One of the electron will come toward one of the carbon, another electron will come toward another carbon. So you'll get 2 free radicals. In borane also, homolysis will occur. You'll get a H free radical. And this H free radical will do what? If this H free radical will attack on CH, leading to the formation of CH2. Now, when this H free radical will get attached to CH, leading to the formation of CH2, the question comes to our mind, what happens to this carbon then? This, see, in borane also there is a homolysis. So you are getting H free radical, along with that you will get a boron free radical. And this boron free radical will form bond with this carbon. It will form bond with this carbon. So the compound I will get is like this: B, then CH2, then CH2, then CH3. This what will happen to a single molecule of propene. Again, there is a homolysis in borane. You are getting H free radical. Along with that, you are getting a boron free radical. The H free radical will combine with CH free radical, leading to the formation of CH2. The boron free radical will combine with CH2, leading to the formation of a molecule like this. And since you got three molecules of propene, so this reaction will take place three times. So another molecule I will get again in the same way, that is CH3, that is CH2, CH2, CH3, then again CH2, CH2, CH3. Well, this compound is tripropyl borane. This compound is then reacted with hydrogen peroxide, H2O2. Before showing you that reaction, let me show you how this hydrogen peroxide reacts. What is the function of hydrogen peroxide? Well, hydrogen peroxide can act as an oxidizing as well as reducing agent. Here in this case, it is acting as an oxidizing agent. Suppose you have got H2O2, it will gain 2 moles of electrons and will become 2 moles of OH negative. Here in this case, you have got 3 moles of H2O2. If you have got 3 moles of H2O2, that means that will give you 6 moles of OH negative ion. Out of those 6 moles of OH negative ion, 3 OH negative are going to combine with this carbon, with this carbon, with this carbon. When 3 OH they will combine with this, starting from this side, what molecule I am getting? The molecule which I am getting from this side is CH3, CH2, CH2, OH. How many times? 3 times. CH3, CH2, CH2OH, CH3, CH2, CH2OH, CH3, CH2, CH2OH. So 3 OH they are going to combine with this propyl group and they are going to form N-propanol. So here I am getting propane 1-ol. Rest of the 3 OH they will combine with boron, and on combining with boron they will form BOH whole thrice, that is boric acid. So here you are noticing anti-Markovnikov addition, and this is how we can prepare alcohols from alkenes by hydrolysis and by hydroboration oxidation. Next we'll see preparation from 1 degree alcohol. How to prepare alcohols from 1 degree? I'm extremely sorry, not from 1 degree alcohol, because we are preparing alcohols from 1 degree amines. From 1 degree amines. How to prepare alcohol from primary amines? No doubt I am using primary amine, I'll get primary alcohol only. Say I've got a compound CH3, CH2, NH2. In this case, I have to react it with nitrous acid, that is HNO2. I can write this nitrous acid as HONO. What we can do, we can divide this compound into 3 parts, that is first part, second part and third part. Likewise, we can divide this compound also in 3 parts, first part, second part and third part. The first part of nitrous acid will combine with this ethyl group and I will get ethanol. The second part will combine with second part, leading to the formation of nitrogen molecule. The third part will combine with oxygen, leading to the formation of H2. So this is how we can prepare alcohols. Again a recap, alcohols can be prepared from alkyl halide by reaction with aqueous KOH. They can be prepared from aldehyde and ketone by their reduction or by reaction with Grignard's reagent. By reduction, we get only 1 degree and 2 degree alcohol, and by reaction with Grignard's reagent, we get primary, secondary, and tertiary alcohols. Formaldehyde will give us primary, any other aldehyde will give us secondary, and ketones will give us tertiary. After that, we did preparation from alkenes, that is hydrolysis and hydroboration oxidation. And after that, we did preparation from primary amines. Primary amines on reaction with nitrous acid gives us alcohols. So this is all about today's class. In the next class, we'll be doing preparation of phenols.